So you've made yourself an oval turning chuck device, and then you realise that you haven't got any wood that's really good for making what you want to make with it. Is the position I'm in. So I thought, well, I'll try segmenting an oval box or bowl, but there's nothing available on the internet, so this is the best I can come up with. I'm using the mathematical construction for geometrical construction for an oval, which isn't a true oval, but for the purposes of segmenting, it's close enough, and we'll find out what the difference is when I turn it. So start with the line, and this is just the standard construction of an oval, and I'm working with the ratio of 3:2 being quite a pleasing ratio for ovals, and this construction method lends itself to that. And I drew a series of ovals using the chuck on a piece of wood, and the one that I picked out as being the pleasing sort of proportion of width to height was 3:2. So this is going to work well for transferring to the true geometry of an oval from this. So if I'm doing box, say this is 100, so I'm going to do two circles 50mm in diameter, so 25mm in radius, and from the first one I'm going to mark the centre of the second one and draw another circle. So I've got two circles. I'll zoom in a little bit. There we go. Now from there, right, find the intersection of the line and the outside of the circumference and mark off those two 60-degree segments on both ends. There we go. Now the next thing you want to do is set your compass to the, you won't need all of this, by the way, but it's just so that you can understand what to do, to the diameter, and then from the centres of the circles, we'll bisect the line for between those. So from the centres, just we're bisecting that line from the centres effectively with using the diameter, and we're finding 2 points there and there. And then we want to set the compass to, from one of those points to one of those 60-degree segments on one of the circles. So there, and draw an arc round to the other, and then do the same on the other side. Draw an arc round from the other, and that's how you construct an oval one way. It's an approximate oval, but good enough for segmenting, I'm sure. So let me just put that lid on. Don't like my pens drying out, I like them to last. They're not cheap. I'm going to draw those lines in. Out to those 60-degree. So we've got 60-degree, 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 60-degree. And then from the points here, I'm going to put lines out to there, out to the where they intersect the arcs intersect, and also a line between those two centres. So now this big arc, a part of this big circle, that we could draw the whole circle, but we're not going to. We've got two 30-degree, because if you put the compass across there, it's 60 degrees. So we've got two 30-degree segments there, and we're going to half those. So however you want to do it, divide them into two. I've got a quick, this is a quick release compass. I don't know why I don't use that feature more, but still. So from there to there, and what we've effectively done now is divided this arc into four 15-degree segments. Now I cheated here because I'm going to divide these end 120 degrees into three. So I used a protractor. There's no way to divide an angle into three using compass, so I used a protractor. There might be a way of finding 40 degrees, I'm not sure. So we've got three 40-degree segments and four 15-degree segments. Does half of the oval. So 8 15-degree segments and 6 40-degree segments. So is it? Yeah, 40 degrees. So those are 40 degrees. 15, 30, yeah, 15, and these are 15 degrees, but to a different radius, obviously. And if you measure that, you'll find that that's 66.5-ish. The proportion of this is 100 to 67, so it's just about on the 2 to 3 width to length ratio, so that pleasing size. And it turns out that these arcs, the length of these segments is a little bit less than the length of these segments. I think it's a fifth. These are a fifth smaller, but they're the fact that everything's uniform side to side, it's symmetrical, it shouldn't be that noticeable. And I saw a couple of videos where people try segmenting ovals by really essentially segmenting a circle and turning it into an oval, or using some bizarre two different size segments to which looked horrendous, where you got thin and wide and thin and something else, and it just looked terrible in my opinion. So this is a way of doing it where it's close enough for sure that it's gonna not be noticeable that the segments are different size at either end, I think. And I can try drawing that onto the true ellipse and seeing how it varies, and whether that's going to get us closer to proper segmentation or not. Anyway, that's the method I've come up with. So thanks for watching.